So page 384, lesson 3. Here's the question we want to ask today. Here's the problem we want to answer. Don't write this down. If I said this, solve, and I say to you 3x plus 6 equals, oh heck, whoop, wrong button. 3x equals 6. What's the answer in your head, please? 3 times what equals 6? Screen coming back? There we go. Kayla? Now, if you couldn't do it in your head, got a bad connection here? If it keeps happening, let me know. If you couldn't do it in your head, what you would try and do, Nicole, your strategy would be to get the x by itself. You would say, well, I'll divide by 3, I'll divide by 3, here the 3's cancel, and I get x equals 6 over 3, which is 2. What if instead we said this? 3x squared minus 6x equals 5. Now, first of all, what kind of an equation is this? And I'll give you a hint. It's got a squared, so what do you think we're going to call it? Do you remember? It's a quadratic equation. The problem, Joel, is there's an x squared there and an x there. If I tried getting the x by itself, I might be tempted to minus 3x squared from both sides, and that would give me negative 6x equals 5 minus 3x squared, and then I might try dividing by negative 6. But that doesn't help, because even though I've got the x by itself, Joel, what do I have over here? I don't know what x is. Doesn't help me. Or if I tried getting the x squared by itself, Joel, I'd end up with an x on the other side that I didn't know. The method of trying to get the x by itself, Rachel, breaks down as soon as you have exponents on your x's. If you have x's with different exponents. Stuck. Well, no, we're not. But Cole, what we're going to have to do is now give you an entirely different approach, different method for solving what we call higher order degree equations. The first of which is a quadratic. It's got a squared. And then in Foundations 12, we'll look at a cubic, which has an x cubed, or a quartic, which has an x to the fourth. In fact, we'll show you how to solve an x cubed, and we'll say it works for anything above there. We just whittle it down. You see the problem, Emma? We can't get the x by itself because it appears in 2 locations, and we can't gather like terms because they're not like terms. I'm stuck with it. So that's the first thing we're going to keep in mind. The second thing we're going to keep in mind is something called the zero principle. The zero principle says this, or it asks this: what's the easiest times table of them all? Easier than the 1 times table, easier than the 2 times table. What's the very easiest times table? The 0. Because what's 5 times 0, David? What's 1,000,000 times 0? What's negative 1,000,000,000 times 0? But I'm going to reverse the question. David, suppose I told you that A times B worked out to be 0. Suppose I told you the answer was 0 and we were multiplying. What can you assume about one of those numbers, A or B? One of them had to be a what? Had to be a 0. We call that the zero principle. If you multiply and you get 0 as an answer, one of your numbers had to be a 0. Does that make sense, Zach? Did I say multiply? Factor, which is what we spent a couple of days doing. You ready? Let's put all that together. It says, investigating the zero product law. The equation x minus 3 equals 0 is only true. Can you solve that in your head? What take away 3 is 0? And I'd like you to try and solve these in your head. We're going to try and get to the point, Jacob, where we can reach a certain point and then jump to the solution in our heads, showing no work for the remainder of it. What does x have to be for this statement to be true? 3. The equation x plus 1 is 0 is true only if what? What does x have to be? Negative 1. Suppose I gave you this factored equation, x minus 3 in brackets and x plus 1 in brackets. What we're really saying is that either this had to work out to a 0, or that had to work out to a 0. This is just like I wrote earlier with that A times B equals 0, except, Rachel, instead of A being a single letter, it's a term, and instead of B being a single letter, it's a term. What I'm suggesting to you is this equation is only true if x equals what or what? What would make this work out to a 0? And I'll give you a hint. You just did it right here. What would make this work out to a 0? If I give you, Tatiana, an equation in factored form and it works out to 0, what we're really saying is each of the brackets could have worked out to a 0. And usually, Tatiana, we can solve the bracket in our head. For example, if I gave you this, can you tell me the answers to this equation? What would make that work out to 0? 7. What would make that work out to 0? Now, I'm rarely going to give it to you this way. I will today. Usually I'm going to give it to you this way. What kind of an equation is this, Joel? How do you know? What you would do is you would factor this. And you know what it factors into? It factors into and then you can get the answers. That's how we're going to solve these, Shaylin. We're going to say, first of all, make it equal to 0 if it's not equal to 0 already, and then factor it, and looking at the brackets will tell you the answers. There's 2 answers. Fancy word, we call these the roots of the equation because it's more than one answer. So saying the answer doesn't sound grammatically correct because there are 2 of them. So we say, Nicole, what are the roots? What about this here? Now, this is exactly the same as this example, except, Tatiana, what's the only difference between this expression and that expression? A 2 in front. Okay? Is that 2 going to make any difference? Well, here's what we're really saying. 2 times something was 0. I think the first something or the second something still has to be 0. Zach, our roots are still and have you borrowed a piece of paper to write this down yet? Otherwise, you're going to be in after school writing out the notes. No, you need to physically make an effort to ask a neighbor to borrow a piece of paper. Thank you. So write some of this down. What about here? I'll give you a hint. Look at the bracket. What would make that bracket work out to 0? What would make a 2x work out to 0? Now, if you're not sure, off in the margin, you can write this. What we're really saying, Joe, is what would make a 2x equal 0? 2 times what is 0? The roots of that equation are 0 and -1. We call this the zero product law, or the zero principle. It says, look, David, if you can write an equation as something times something times something times something times something, and they all equal 0, you know that each little individual something must have worked out to a 0 on its own for that to be true. Okay? The last 3 statements in the investigation above are what's called the zero product law, which states the following. If you have the product of multiple factors and it's equal to 0, then at least one of the factors must be equal to 0, or both, but at least one of them. In shorthand notation, Colleen, it says this. If A times B equals 0, then either A equals 0 or B equals 0. So let's suppose I gave you something that factored like this. This factor times this factor equals 0. What are the roots? What are the answers? Well, what you really do is you pick up the first factor.
The following students need to come to the office.
That again. What I would do is I would, if I can't do these in my head, I would pick up the first bracket, and Joel, I would say that has to be 0. I get the, now there isn't a squared on the x. I can get the x by itself. How? I would minus 1 from both sides. And then what's the 2 doing to the x mathematically? Timesing, so how will I move the 2 over? X equals negative a half. There's one of the roots. Let's try this. I would pick this bracket up. I would be saying this bracket could be 0. How would I get this bracket by itself? How would I get this x by itself? How would I? Kiara. Okay, you back with me? How would I get the x by itself? Later, don't divide first. How would I move the 7 over? What's in front of it? So what will I do? Okay, I would get, and then these are the roots of this quadratic equation. The roots of this quadratic equation are negative a half and 7 over 3. And I can prove it to you. I can verify it if you want me to. I can go like this. So one of the answers was negative a half, so I can go 2 times negative a half plus 1 bracket, bracket. 3 times negative a half minus 7, close bracket, 0. It works. Typing that in for the x. Or if I typed in the 7 over 3 there and there, it would work too. It is actually the solution to the equation. So it says verify. I'm not going to bother verifying. I'm just going to be careful on my way. Next page. Okay. It says an equation is solved by stating the values of the variable which makes the left side and the right side equal. These values are said to satisfy the equation. Values that satisfy, here's your new word. We're going to call these the roots of the equation. So Rachel, the roots of the quadratic in example 1 are negative a half and 7 over 3. Okay. They go into a big specific song and dance. Don't worry about that too much. I'm not that fussy. What I want to get to is example 2. I want to start to solve these. And we want to reach the point, Nicole, where we can solve these almost in our head. Here's what I mean. Here's an equation. First thing I double check, Kayla, is it equal to 0? Then I can use my 0 principle. Is it factored? Yeah, okay. What are my roots? From that bracket, what's the root? I agree. From that bracket, what's the root? What would make that work out to 0? What plus 8 is 0? I'll give you a hint. 8 plus 8 ain't 0. Huh? Negative 8. Don't write this down, just watch. What are the roots? What are the roots? What are the roots? Uh-oh, trick here. Do the second bracket, because that one you've already figured out. What's the root of this, Ashley? Negative 6. You're just asking what makes it equal to 0. What are the roots? What makes an x work out to 0? It's so easy that it's tough. I heard it. 0. When you have an x just by itself, 0 is one of your roots. What are the roots? This is actually math 12, but that's okay. There's 3 roots. What are they? 0, 7, And? Spotted the shortcut? The tricky part is getting them factored. That's what takes the long part. But hopefully, Emma, once it's factored, you can see the roots right away. You're sort of changing the sign, but you're solving an equation in your head. Do one more. What are the roots? Do the easy one. -6, yes? It's not 5. What you're really saying, remember, is this. You're asking, what makes that 0? 5 times what is 0? Ashley, yeah, the coefficient in the front doesn't change the fact that there's just an x there. It's 0 still. What are the roots? Zero and -10. What if there was a 6 in front of there? Still 0 and -10. Okay? What are the roots? Stop. More patterns. 5x plus 2, 6x minus 1. I'm going to tell you right now the roots are -2/5 and 1/6. How did I do it that fast? Can you see it? Can you? 3x plus 4, 7x minus 9. The roots are -4/3 and 9/7. Sorry? Okay, I'm going to use, she said the last number changed. I got to be careful because I could have put the 4 in front of the 3x. Here's the shortcut when they give you one of these ones. And did we just do a bunch of factoring where we ended up with those kind of expressions as our factors? Yes? That was the decomposition method, so I want to show you a shortcut for that. It's change the sign of the constant, divide by the coefficient. Change the sign of the constant, divide by the coefficient. What are the roots? Kiara. I agree. I agree. I agree. See the shortcut? Yeah. It's worth, that's one of the few times, Cole, I'm going to say to you, worth memorizing because it's such a huge time saver. Otherwise, here's what you would do. You would say, okay, Dueck, I got the 0, okay. Here I would go, that could have worked out to 0. I'll -7 from both sides. I'll divide by 3. I get that. What I'm saying, Joel, is if you spot the pattern, you can go straight to there. It's a good shortcut. What are the roots? Put everything together. Next page. Example 4. What if they don't give me the equation factored? All right. Here's the whole point. This is the new stuff. Zach, my friend, what kind of an equation is this? Quadratic. How do I know? Okay. How do I solve a quadratic? First thing you have to do is you have to make it equal to 0. Is it equal to 0 already? Good. Then we factor. Because this is not factored. The roots are not 14 and 5 or something. I don't know what they are. I've got to write it as brackets. What's the first thing that I always, huh? Is there a GCF? There's an X in those two, but not in all three. No. Be nice. How many terms are there, Jacob? Nope. Here. 3. How do these ones factor? Oh, check the quadratic term. Is there something in front of the squared term? Then this factors by what we called inspection. We said you're going to look for two numbers that multiply to negative 14, and add to negative 5. It's going to factor into two brackets. It's going to factor into what and what? X, or do you say minus 7? X minus 7, x plus 2. What are my roots? What are the roots? And I'll prove to you that this works. See this equation? If I go 7 squared minus 5 times 7 minus 14, it does work out to 0. Or if I go negative 2 squared minus 5 times negative 2 minus 14, that also works out to 0. Those are the only two that work. No other numbers will work in that equation. Those are the roots. Those are the solutions. B. Adrian, what kind of an equation is this? It's right there, read. It's right there too, yes? How do you know? Okay. To solve a quadratic, we have to factor it. Oh, but first we have to make it equal to 0. Is it already equal to 0? Is it already equal to 0? Say yes. Get the hand, but the bottle away from your mouth. You're not a little baby anymore. Sorry? Yes. Okay. How does this one factor? What's the first thing that I always... Oh, okay. Is there a greatest common factor? Not a 5, not an x, not a 4. No. How many terms are there on the left-hand side? 2. Is there a minus sign? Is this a perfect square? Yeah, it is. Is this a perfect square? Okay, we called this one difference of squares. How's that factor? Sorry? You the man. Oh, we're not done. We've just factored it. Now we're actually solving it because it's an equation equal to 0. What are the roots? Remember the shortcut? Negative 5 over 2, comma. See it, Tatiana? Okay, say your name, Tatiana. Sometimes as a shortcut, because we're lazy in math, we may actually just write it like this. Plus or minus 5 over 2, because it's the same number positive and the same number negative. You may see it, the answer key, just say plus or minus 5 over 2. Is that okay? Let's keep going. Tatiana, what kind of an equation is this? How do you know? Okay, to solve a quadratic, I have to make it equal to 0. Is it equal to 0 already? Yeah. By the way, the next step is we're going to say, what if they're all jumbled up and mixed up and not equal to 0? We'll have to do some algebra. Okay. How do we solve a quadratic once it's equal to 0? It's the math F word. We factor, not the F word you're thinking of. Factor. How do I factor? What's the first thing that I always... Is there one? Yeah? What? Oh, 10x? Okay. Let's factor out a 10x. What would be left behind? And a minus. Sorry? Yeah? What are the roots? And if you're not sure about the first thing, do the bracket, because those are usually actually easier, even though they look uglier. Huh? What's the root there? 9? What here? Ah, 0. Is that okay, Rachel? 2 more and we're done. When you got a coefficient in front of the x there. By the way, you do it all the time, but what is the invisible coefficient right there? It's invisible, but what's sitting there? Yeah, see, it's technically 9 over 1. Do we ever write the over 1? But that's really what you were doing even over here. You were saying, oh, change the sign, divide by the 1. Change the sign, divide by the 1. Change the sign, divide by the coefficient. Change the sign, divide by the coefficient. It's the same pattern the whole time. But yep. D. By the way, do you notice, Rob, that D looks very, 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 very similar to C? Okay. What kind of an equation is this, Rob? How do you know? Okay. How do I solve a quadratic? First thing I got to do is make it equal to 0. By the way, look up. You see, I could have given you this equation like this. It's not the same equation. Look closely. If I'd given it to you like that, you'd have to make it equal to 0. How? You would minus the 90 over to this side. Okay? That's going to be in the next couple of examples, but that's why I'm always adding that. Don't just start factoring. First, you got to make sure it's equal to 0. Now, is it equal to 0? And I know it's a quadratic, then I'm going to factor to solve. Factor out of 10, you mean? Sure thing. And I'll get x squared minus 9 equals 0. And I'm not done. Because look at that bracket. What kind of a bracket is that? It's a quadratic. How do I know? It's got a squared. That means I'll bet you it breaks down further too. I'll drop the 10 down. What does x squared minus 9 factor into? X minus... What are your roots? Now, from here, 3. From here, so I'm going to write, because I'm lazy, plus or minus 3, because it's plus or minus 3. What about from here? Is there an x in front there? Then that's not going to do anything. That's not going to give you a new root or anything like that. It's just going to make the equation look different, but not change the actual answers. Is that okay, Emma? 2 more, we're done. Says, when solving a quadratic equation by factoring, the quadratic equation must have all the terms on one side of the equation and 0 on the other side. You know what? That's worth underlining. You have to make it equal to 0. Oh, and then it adds one more point, Nicole. It says, by the way, it's usually easier to factor if the x squared is positive. So let's first of all look at this one here. What kind of an equation is this? Jacob, when I get rid of brackets, it's going to be a quadratic. Can you see that an x squared will pop up? Okay. How do I solve a quadratic? What's the first thing I have to do before I do anything else? Before I do that even, I have to make it equal to... So here's what I'm going to do. Is this equal to 0 right now, Emma? Then I have to get rid of all brackets. And I need to rearrange this. I need to minus and plus things to both sides until it is equal to 0. What would be the easiest way to make this equal to 0? How would I move the 5 over? What's in front there? It's invisible. Positive, so I will go. And it's not minus 5x, it's just a minus 5 is going to appear on the end. I'm going to end up with this. X squared minus 4x. 4x, Mr. Dueck. 4x, Mr. Dueck. Good gosh. Minus 5 equals 0. Tasha, you going to make it? Okay. What kind of an equation is this, Chelsea? How do I know? Okay, how do I solve it? Jacob, is it equal to 0 now? Ah, now I can factor. Factor this. Find the roots on your own. Go. Factor it. Find the roots. Go. No GCF. Oh, but this is a nicer one. There's nothing in front of the squared term. What'd you get for the roots? With that? No, if you say -1 and 5, that's fine, but make sure the 5 is positive and the 1 is negative. B. What kind of an equation is this, Alexis? Quadratic. How do you know? Okay, to solve it, I need to make it equal to 0. Now, I have a preference. I could plus both of these over. I hate the quadratic term to be negative. So I will always, if I have a choice, if I have a negative quadratic, I will always plus it to the other side and make this side equal to 0. Because then I don't have to invent a whole new brand of factoring. So I'm going to go like this. Shalom, what will I have left over on this side when I go -3x squared plus 3x squared? It's meant to be really, it's a trick question. It's so easy that it's tricky. 0, yeah. Over here, Joel, instead of writing -13x minus 10 plus 3x squared, I'm going to write it in the order that I like. The squared term, then the x term, then the constant term. I'm going to write it as positive 3x squared minus 13x minus 10. That's the same equation. No. But I'll keep it over on this side just to let you get used to the fact that sometimes it will show up on the left. Okay. Joel, what kind of an equation is this? Okay. Is it equal to 0? Let's factor. Oh, this is going to be that decomposition method. Can you see I got something in front? And Nicole, by the way, as soon as I have a quadratic trinomial with something in front of the x squared, I'm going to end up with brackets much more like these style, where I got something in front of the x's later on too. How am I going to factor this? I'm not looking for two numbers that multiply to -10 and add to -13. I'm looking for two numbers that multiply to what and add to what? And add to -13. I'm going to drop my 0 and my equals down. Remember we said for these ones we drop the 3x squared and we drop the -10 down. But we're going to decompose, we're going to break this up into its constituent parts. What are two numbers that multiply to -30 and add to -13? I was thinking at first -10 and 3, except -10 plus +3 gives me a 7. Actually, I think it's the 15 and 2 combination, right? 30's a tricky one, by the way. 30 and 6 is also bad, because 5 and 1 and 2 and 3, I always get those mixed up, because 2 and 3 add to 5. Anyways, I factor that one wrong all the time. I factor 30 wrong very often. So I think 15 and 2, which one's positive, which one's negative? Well, if we want them to add to a negative, we want the bigger number to be negative. So then we draw a line down the middle. Drop the 0, drop the equals down. GCF, remember this? Out of the first two terms. Emma, what is it? I totally agree. x minus 5. Oh, our error check is we should get the same bracket in the second one. I hope. GCF out of the last two terms, Emma, my child. I totally agree. Do you also get x minus 5? Okay. So factored, this is x minus 5, 3x plus 2. But now, Rachel, this is an actual equation. They didn't just say factor, they said solve. What are my roots? Positive 5, negative 2 over 3. Quadratic. That's how we're going to solve quadratics. We're going to make them equal to 0 if they're not already. And then we're going to factor them. And then once we've factored them, we find the roots, the solutions, the equations hidden in the factors. We say, what would make each factor work out to 0? Although Rob hopefully has gone beyond that, where we're just seeing what the roots are without having to ask that question. What's your homework? Number 1, all. These ones are factored already. Number 2, all. These ones are factored already. Yes, I did say that already. Paying attention, are we? Number 3. Number 4 is a little word problem, but they gave me the equation, and Natasha, I'm pretty sure it's a quadratic, and I think it's telling me that the roots are the length and the width, so I think what they're saying in number 4 is find the roots, and that'll tell you the length and the width of the swimming pool. Okay. 5 is good. Now if we look at number 7, this is going to be the decomposition method. This is where we're going to, the roots are going to be a bit yuckier. They're going to be fractions. It's going to be change the sign, divide by the coefficient. So number 7, all. Number 9. Number 11. Okay. And then you're also, if you finish these, you can also work on the factoring sheet. Some of you may get this done today. We're only going to be doing one more lesson for the year. The last lesson is going to be something called the quadratic formula. And what it asks is this. What if instead of having which factors, what if you have which doesn't? We're going to ask, is there a way to deal with equations that don't factor? Yes, but it's long, which is why we always prefer to factor. Most of the factoring, Emma, we can do in our head. The quadratic formula is lots of calcular work, but it is nerdily cool. So that's a preview of coming attractions. We'll also start working in some review, and we'll start working towards our final exam. Let me just pause the recording for a second.